Okay, the Doppler effect is an important idea that we should understand when we're talking about light and sound. It's also going to be an important concept later on in the year when we are talking about the universe in outer space. And you have experienced the Doppler effect in day-to-day living whenever a siren or an ambulance or an emergency vehicle drives past you very quickly. And so hopefully you can hear the sound of the siren when I play it. And I want you to notice the pitch, not the volume. It's going to get louder and softer, but the way it sounds, the pitch of it, the tone of it is going to change as it's coming to us and as it's driving away. Alright, so hopefully you heard that. Maybe if I don't know. Hopefully that's not too loud. Hopefully you noticed the pitch as it was coming to us. It was a much higher tone, and then as it was driving away, the sound of it, it deepened, and it was a lower sound. We'll do it one more time. Alright, so that's Doppler effect. So if we first look at how sound will travel in a vehicle in the siren that isn't moving, so this ambulance here is just sitting there, and if it plays its siren, well, of course the sound is going to travel in all directions, right? It's going to travel everywhere, 360 degrees around it. And since it's not moving, the sound will be the same from all around its perimeter. So in every direction, all the sound waves will have the same frequency. So if these lines represented the crests, I could draw the wave kind of like this. And then the waves would be exactly the same, if I drew it better, would be exactly the same on the other side. So whether or not, if we are standing here, or if we are standing here, or anywhere else around the circle, the sound of that siren will be the same. However, if the vehicle is moving and traveling in this direction, okay, what's going to happen is those sound waves are going to compress in the direction that it's traveling. So on this side, the sound waves are going to get squeezed together because of the speed of the traveling siren. So the waves would be this small, something like that. Where behind the vehicle, behind the siren, the waves are going to stretch out. So we're going to get something like this, and the waves are much longer, and the frequency is much lower. So if we are standing here, we're going to hear a much different sound than if we were standing here, because the frequencies are going to be so different. And that's why we heard the siren in two different pitches. When it was coming toward us, we heard a sound wave that looked like that. When it was traveling away from us, we heard a sound wave that was like that. Okay, and this also occurs with light, not just sound. So here, if we take a telescope and we're looking out at the stars, if a star is traveling toward us, then just like the ambulance, the waves are going to get squeezed together. Behind it, it's going to get stretched out. Alright? And so when that happens, we're going to see a tint of blue in that star, which is called the blue shift. Alright? So instead of pitch, the frequency of light is going to change the color of the light. So if it is a frequency that's squeezed together and fast, right, it'll be more of a blue tint. On the other hand, if the star is going away from us, then the waves are going to be squeezed over here, right, and it'll be stretched out over here, and the waves are going to be really stretched out, a lower frequency, and so we're going to see that star in a redshift. It'll have a red tint to it when we look at it through the telescope. And what we found when we look at all the stars in the universe, we look around and just about all the stars that we see are traveling away from us. So why is that important? Well, it's important because it indicates that our universe is just expanding. Right? Nothing is coming toward us, everything is stretching away. And so if everything is stretching out and moving away from us, then that means our universe is stretching out and getting larger and larger and larger. All right? And that whole idea leads right into how the idea of the Big Bang started out, but that's a topic for another video. All right. So again, Doppler effect, sound and light. We perceive sound and light differently if the sound is coming toward us, or the light is coming toward us, or the sound or light is moving away from us.